Hello, this is Drew with MicroStation tutorial video number 2. Last video we made an alignment. This video we're going to make a profile. We can just keep the same MicroStation file, make a copy of it, name it PFL, and open it up. Once we have our copied alignment file open, we can just delete the stuff out of here. If we want to see it again in this file, we can always just reference it back in. Again, the first step is to open the road tools and go to your project manager. The GPK folder that you created last time will still have your project folder in it, so you open the same project, same user. This time, we're going to do existing ground profile, which is to lay out where the ground is beneath the road you're about to build, which in our case is beneath that yellow line we just stored as a horizontal alignment. Under existing profile, we're going to do a run. Let's do a new run, name it video 2. Open this, we get this little dialog box. We're going to name the profile for this example video PFL. We have the same job number as the alignment, same operator code. The chain is the chain that we created in the last video. We named it chain 1. Here it is. It automatically populates your beginning station and station. If you clear them out and re-enter them, you can make sure they populate correctly. We're going to use a tin as a surface, increment every 5 feet, tin. You're going to need to insert your tin file here. If you don't have a tin file for your project, you can look at the description and there's resources there that will allow you to find them online. After your tin is loaded up, you're going to hit apply. This is the default input file name. Change it to vid2. Your stored profile has been created. Do you want to store a profile? Yes. Would you like to delete 3D profile string? Yes. Doesn't matter. You can close this window now. No. Close this window. What we're going to do in a minute is come back here to vertical alignment settings. But before that, we're going to display the profile we just made. So we're going to go back to our paintbrush tool, English scale, vertical alignments this time. And we just made the existing, so we're going to click on the existing vertical profile paintbrush tool right here. We want to draw a profile. We named our profile video PFL. There's more settings here that can make it show more details as you want. You should check to make sure your station ranges are correct. Our stations go from 10 to 16, so that's right. Horizontal and vertical scale can be convenient if you want to visualize it differently. Now, we need to identify the horizontal chain along which this alignment is going to show up. We use chain 1 from our previous video. Then we can specify location and draw our cell. This is where it's going to put our alignment into. And there it is. That's the vertical alignment along the chain we created. The next step is to create the proposed grade and impose it on top of the existing grade here. To do that, we're going to go out of the paintbrush, go back to our project manager, and open vertical alignment. After we open the vertical alignment tool, we don't need to worry about this stuff in here. We just need to identify the cell that we just created. It'll automatically populate it with all the info we need. You can hit OK, and it's going to bring up the profile generator tool. This tool can be quite finicky, but I'm going to try to give you a general example of how it works. Basically, you're going to set these points along the profile that act as inflection points where you want the road to bend, and it will draw a line that fits between them in a smooth fashion. So we're going to want to start it tying into the existing ground surface, might be road surface. So we're going to snap it onto this point after we click dynamic. Click to accept, and now that's our first point in our chain. For the second point, we're just going to lock in the starting grade. So we're going to insert a point, click dynamic, and once you get close to this, it'll kind of drag it out and you can see where it's going to attach to. We're going to attach it near this crest of the road right here. And now that we have this little slope, we can go back to our first point, or right here. our back grade. We want to lock that. So that means after we continue adding points, that it will keep this grade right here. You want to make sure your grade is appropriate for your road type, your conditions, terrain, and all that. After you add VPI 3, the general idea of this is you want to get your road to fit as closely to the ground as possible to avoid having too much cut or fill. Once you have your VPI points in a location where you think you can fit a curve to, having them more spaced out is generally easier because you have more room to work with. But then you go back and you can set your speed. We'll go with 35, which is nice and low, so it'll be easier to fit in more curves. As you can see, it'll draw a curve right there. This is like the max slope you can have for a 35-mile-per-hour curve. And as you move the VPI point, it'll bring your curve up and down. So after playing around with this a little bit, I got some points in here. One of the key things you have to pay attention to is if your curve goes out of range. So for example, if I wanted to bring this curve lower to cut down on all this fill we're going to have to do, I would take my dynamic, lower it down a little bit. But as you can see, it starts to overlap here. And when we go back to look at this station, you can see that we're out of range. So to fix that, we're going to have to bring it back up. That's just a constraint of how steep you can make roads, given our design speed. So there it fits in well, and it will curve along here, fill in all this area, and it dips back down. For this next section over here, we're going to want to slope it the opposite direction because here you see we're going back up in elevation. This VPI point right here is basically the low point of this curve. As you can see, you can move it back and forth. Generally, what you want to try to do is hit it somewhere in between these slopes so you can balance out the cut and fill. We have a lot of fill over here already, so we can go a little low on this one. Okay, so you see now we have this curve here and this super curve here. It might be a bit of a roller coaster of a road, but for example, it works out. Again, I tied it back into this existing grade. Normally you're building roads between two existing roads. Well, a lot of times it might not be the case here, but tying it to the existing grade is something you will do a lot. As we click through the VPI points, you can see there's no overlap, so it would accept this alignment if we tried to print it out. So it accepted the profile, it's stored, and now we're going to use the paintbrush tool to display it. Again, back to the paintbrush over here. This time we're going to go to vertical alignment proposed. We're still on the 100 scale, so we're going to take this first. Propose vertical alignment option. Draw a plane and profile. Same job number as before. The profile we just made is called vid to prop. We're going to identify the cell we want it to be drawn in. Still along the same chain. Stations look correct. Reference station, reference elevation. I'm going to hit OK. It's going to drop in a curve with a whole bunch of preferences I didn't set, so it's kind of just random. But as you can see, the yellow line is the actual curve of the road. Lots of great information. This is all stuff you're going to determine before with your roadway design criteria. You're going to know what your max grade is. You're going to know what your max vertical curve, K value, all that. So generally what you want to do is get it to follow the ground as closely as possible. As you can see here, a lot of fill, a little bit of fill, and some cut in here. After a quick and dirty estimation of our cut and fill, where I took the area of the shape that is fill and the area of the shape that is cut and multiply them by 24 because there's two 12-foot lanes. This is what it gave us. So I'm going to go back and try to bring this curve down to balance it out a little more. After one iteration of going back through the profile, I brought this VPI out to the right a little more, and I dropped this one down a little bit lower to balance out. So this is the results of the cut and fill. It looks more balanced now. It's only a difference of like 20,000, a little less than, when before it was much greater. That about does it for video 2. Now after this video, you should have a vertical alignment stored. After watching the first video, you have your horizontal alignment stored. The next step would be to combine them into a 3D model. These first two steps took about 10 minutes each in video form, so I'm guessing the 3D part will probably take 20 or so minutes, so that might be a future video on my channel. Thank you for watching.